Hello everyone. In this video, we will understand the addition of one-dimensional and two-dimensional array elements using pointer concept. Before we look into the program, we'll understand what is a pointer, how do we declare a pointer, and how do we initialize a pointer to a variable and an array. A pointer is a variable that holds the address of another variable. So if a is a variable that stores some value, a pointer is a variable that stores the address of this variable. Every variable has an address. Let us assume the address of this variable is 1000. Now the pointer stores the address of this variable. Right? How do we declare a pointer? A pointer also has a data type and a name. So we have data type followed by star and a pointer name. So if I want a pointer to store the address of an integer variable, I will be declaring it as int star ptr. To initialize a pointer variable, we make use of address operator. So how do I assign the address of a to a pointer? It is like this. This is with respect to a variable and a pointer. Now the things are slightly different when we consider an array. Array is a homogeneous collection of elements under a single name. So here A is an array which has 4 elements. The indices of these elements are 0, 1, 2 and 3. Now if I want a pointer to point to this array, I have to assign the address of the array to a pointer. In case of arrays, the name of an array is itself its address. That is, A is nothing but the address of this array A. So when I assign P is equal to A, it basically means I am storing the address of A into P. So P is a pointer to A. This is with respect to one-dimensional array. So ptr name is equal to array name. This is how we initialize an array to a pointer, one-dimensional array to a pointer. With this understanding, we shall have a look at a program to add elements of an array using a pointer. So here I have declared an array to store 10 elements, variables to store the sum and the number of elements as well as one counter as I. I have declared an integer pointer to point to this array. Ask the user to enter the size of an array, read the elements into an array. We have already studied this in our previous video, how to read the elements into an array. Now, as we just understood, the name of an array is itself its address. I will assign the array to a pointer. So ptr is equal to array. So what does this mean? I have a pointer. This is pointing to an array which has n elements into it. Right? To access the elements of a pointer, we make use of a dereferencing operator, that is star. Now I have few elements here, 10, 20, 30 and so on up to 30. Now in order to access these elements using a pointer, I need to make use of dereferencing operator, that is star. Okay, so PTR is pointing to the first element of an array. To go to the second element, if I want a pointer to point to the second element of an array, I need to just increment this pointer by 1. So here if you observe, sum is equal to sum plus star of PTR, that is access the element at that address and increment the pointer by 1. So this is how we add the elements of an array using a pointer. Finally, we'll print the sum, that is the value stored in a sum variable. So this is how we add the elements of a single dimensional array using pointers. Now coming to two-dimensional array. A two-dimensional array is an array of an array. Though the visualization is like a matrix, but the elements are stored into a memory after every, they are stored in a row ordered format. So if this is a two-dimensional array which has a rows and a column, this is 0th row, this is first row and second row, and every row has 4 elements, or there are 4 columns in every row. Now how is it stored into a memory? This is stored into the memory in this fashion. So 0th row is stored first, 0th row is stored first, 11, 22, 33 and 44, then the first row, then the second row. Observe the address also. This is the base address 2000, 2004, since it is an integer array which occupies every element in this array occupies 4 bytes. So the base address is 4, which has an element 11. At the next address, that is 2004, you have 22, 33 and so on. So 0th row starts at address 2000. First row, it starts at 2016. So you have 4 elements, 2000, 2004, 2008 and 2012. First row has at the address 2016, second row at the address 2032. So if the base address is 2000, I have 4 elements each. Okay, so at 2000 I have the first element plus 4 to it. This is the first element. 2004 will have the second element, 2008 the third element and 2012 the fourth element. Okay, so this is the first row of your two-dimensional array. In the previous sheet, we had observed that the base address, the pointer is assigned with the base address of an array. Now when I want to move from the first row to the second row, I will be incrementing it by 1. So this is how your pointers gets incremented in case of two-dimensional array. We shall just understand that. So array basically points to 0th row of two-dimensional array. So if you observe this figure, here it's pointing to the 0th row. Array plus 1, it points to the second row. Array plus 2, it points to the second row. This is 0th row, this is first row, and this is second row. No matter how many ever elements I have in a column, we just don't bother about it. Okay, in order to go from first row to the next row, okay, we have to just increment it by 1. So in general, array plus I points to the ith row of two-dimensional array. Okay, as we have already discussed, in order to access the elements, we use dereferencing operator. We'll understand this, how it operates in case of two-dimensional array. Okay, now if it is a pointer, this is we just understood with respect to the name of the array. If at all I want to perform the operations using pointer, so how does this go? Star of array plus I, it points to the address of 0th element of an array. Star of array plus I plus 1, just observe. Okay, this points to the first element of the array. Plus 2, it points to the address of second element of an array. So remember, we are just talking about the address now. In order to access the element, okay, I need to put double star in front of this. So I will have something like this, star of plus I plus okay, in order to access the second element. So in general, star of array plus I plus j, it points to the address of jth element of ith row. Okay, how do I access the values? How do I access the values? I need to dereference the same thing. So this is the address part. How to access the values from there? I need to make use of one more star in front of this. Okay, so this is equivalent to the subscript notation, that is I and j. Okay, with this knowledge, we'll understand a program to add two matrix using pointers. Now I define the rows and columns to be of size 3. I define 3 functions. I declare 3 functions: input, print and add. Okay, so with these with the size of rows and columns, and the addition matrix, it takes in 2 input, mat1 and mat2, as well as the result to store the result of the 2 matrices. Okay, now declaration part. To read the input matrix, to find the sum. This is our main function. Now have a look at the functions. So the first function is to read the matrix. So these are the loops for rows and columns. Now I am making use of a pointer here. Okay, star mat of I, mat plus I plus j. So this is basically equivalent to mat I plus j. I am not accessing the values, but I am going to store the values. You have to remember this. Whenever I am accessing the values, I need to mention it as star of mat plus I plus j. But when I am storing the values, that is scanf, I am using a scanf statement here, this is not required. So this is reading the matrix. Print the matrix for the rows index and the column index. As I told you, I need to dereference, I need to access the elements at that position. So I use star of star. Finally, adding 2 matrices. How do I do that? result plus I plus j. At this point I want to store the elements, so this is how I do it. Thing you have to remember here is mat of ij, this is equivalent to star of plus I plus j. I hope you understood the concept. Thank you for watching.